Okay, today in section 8.3, we're going to be talking about trigonometry. This whole section in 8.3 is about trigonometry. And we're going to start out with the simple trig stuff which applies in right triangles only, which is sine, cosine, and tangent. You've seen this before in geometry, you've seen it before in Algebra 1 probably, but we're going to kind of recap. And then tomorrow we're going to talk about something called the law of sines, which you may have already seen in geometry in Algebra 1. And then we're probably going to talk about something you may not have seen, which is called the law of cosines. It kind of just depends on your teacher. In geometry you may have talked about that, but you might not have. And so this whole week is about trigonometry. Your calculator needs to be in the mode of degrees. When you get to pre-calculus, you'll be working a lot with something called radians, but in our class, we work with degrees. Just one piece of vocabulary to begin with. The first thing is about bearing. This is usually when you're navigating with a ship or something to that effect. And so if you were looking at a compass, and let's say maybe you were headed in the following direction, and you knew that this angle right here was 30 degrees, what you might say is 30 degrees west of north. Might be one way they might say it. And if you knew anything about the unit circle, which you'll talk about in pre-calculus, what you'll know is that another way to talk about it, because we talk about degrees and counterclockwise angles, is they may say something like 120 degrees. But in our class, probably the orange is the way things would be said. 30 degrees west of north. In the bubble that you see here, this is kind of a recap of trigonometry with right triangles. This only works with right triangles. That's very important to note. So this is called right triangle trig. And I like to actually use an example that is pretty easy to talk about. So if I look at a triangle that's a right triangle, and I tell you this is angle A over here, and we put the right angle in there so you can see it, and I put down three sides like 3, 4, and 5 for a right triangle, there are three trig ratios that we talk about. The first one is called the sine, which we abbreviate with SIN. And if I'm talking about angle A, it is the opposite side over the hypotenuse, or in other words, 3/5. If I was talking about the cosine of that angle, which I abbreviate with COS, you'll see these buttons on your calculator, and I was talking about that same angle A, that would be the adjacent side 4 to the angle A, divided by the hypotenuse, which is 5. And then the last thing that you would be talking about in our class would be the tangent of A, which we abbreviate with TAN. And that would be the opposite side 3 divided by the adjacent side 4. Now you may have heard, when you first were talking about trigonometry, a certain mnemonic tool, which is a sound tool, to help you remember which one's which, like opposite, adjacent, what. So sine starts with the letter S, and it's the opposite over the hypotenuse, which you may have seen as SOH. And then in the cosine, you see that you have a C, an A, and an H as the first letters of each word that we're talking about. And so they might have talked about that cosine as CAH, that the cosine is the adjacent over the hypotenuse. And the tangent, as you talk about the tangent, with a T, an O, and an A, the sound tool that they would have used for that would be TOA. And so a lot of math teachers talk about remembering this stuff, this right triangle trigonometry, with SOHCAHTOA. Okay, so some of the practical applications of this is, a long time ago when you had better weather, I used to take classes outside and we used this tool that would measure angles, and then we could figure out the height of our flagpole in the front of the school building using right triangle trigonometry. And so if you imagine like these heights on these things are like walls or poles or whatever, you can kind of maybe see a little bit of the practical applications of what we could use this for. But the big idea is to try and figure out what do they give you and what do you want. So as I look at problem number 1, what I notice is there's an angle. And in relationship to this angle, they want the side that's opposite to the angle, and they give you the side that's adjacent to the angle. And if you look back on the previous page, you'll see that when I have an angle, opposite, and adjacent, I'm talking about tangent. So if I were to write a relationship between all the pieces that I see in front of me here, I would tell you that the tangent of the angle that they show me, which is 40 degrees, would have to be the opposite side, x, divided by the adjacent side, 10. If you look at your calculator, you can type in tangent of 40 degrees. So if I go to my calculator, I just go tangent 40 and hit enter. And I see a decimal that represents the tangent of 40 degrees, or in other words, a relationship between sides, even though they talked about an angle. And so what I do is, whenever I see trig stuff, I go to 4 decimals, not 2 like we normally do in our class. We're going to go to 4. So I'm going to write down 0.8391. 0.8391. So 0.8391, which is the tangent of 40 degrees, is going to be equal to x divided by 10. In order to figure out what my x value is, I would have to multiply both sides by 10. So I multiply this side by 10, and I multiply this side by 10. And the reason I'm multiplying by 10 is I see that the right-hand side was divided by 10, so to undo that, I multiply by 10. And if you know anything about how decimals work, you know that when you multiply by 10, you just move the decimal one spot. So I know that my x, or my side that I'm looking for, is 8.391. In these problems, make sure that your calculator is in the mode of degrees, not radians, degrees. Let's look at number 2. Finding the length of the missing side. So now, this time, as I look at number 2, I see an angle, and I see the side that's opposite to it is given to us. And they want the hypotenuse. So I have an angle, opposite, hypotenuse. That means the trig that I have to use is going to be sine. Because the sine of that angle, 22 degrees, will be equal to the opposite side, 14, divided by the hypotenuse, which is unknown. On my calculator now, I can go and type in sine of 22 degrees. So the sine of 22, we should all get the same number, 0.3746. 0.3746. So 0.3746, which was the sine of 22 degrees, should be equal to 14 over x. Now notice how in the first problem, the variable was in the numerator, in the numerator on the top, right? And when the variable was in the numerator, we took this number times the sign. When the variable's in the denominator, we're going to take the 14 divided by this number. It's really like cross multiplying, but it saves a step. So if the letter's on the top, multiply. If the letter's on the bottom, divide. So in order to find my answer, what I'm going to do is I'm going to tell you that my x is going to be equal to that 14 divided by 0.3746. Oops. So I go to my calculator, and I take 14 divided by 0.3746. And I get roughly 37.37. That's funny. And that's my x. Remember, the important thing is we are going to make sure that our trig is 4 decimals. When you find your variable, you can go to 2, but whenever you do your trigonometry, make sure you go to 4. Let's look at number 3. In number 3, again, I'm looking at the piece of information that they talk about. I see the 35 degrees, and then they're looking for the side that's adjacent to that 35 degrees, and they give me the hypotenuse. So I have an angle, adjacent, hypotenuse. That means I have to use cosine. So the cosine of the 35 degree angle is equal to the adjacent over the hypotenuse. I go to my calculator and I find the cosine of 35. Remember, we're going to 4 decimals with trig, so that's 0.8192. 0.8192. So 0.8192 was the cosine of 35. That's equal to x over 15. And now if I want to find my x, since the x is in the numerator of the fraction, I'm going to take the 15 and multiply by the 0.8192. So I take that 0.8192 times, what was it? 15? And I get 12.29. 12.29. So number 1, 2, and 3, we found sides. Look at number 4. What are we finding this time? An angle. So when we find this angle, notice how they want the angle this time, but they give us the side that's opposite to that angle, and they give us the side that's adjacent to that angle. In other words, we don't know anything about the hypotenuse.